Conversions are a major thing we're going to be doing in this course because a lot of times we'll make measurements where they're in one unit, but we want them in another. For example, maybe I measure something on a scale and it's in grams, but I actually want to know how many molecules are in that. So that means we're going to have to go through some steps to figure out how to get from one unit to another, because one tends to be what we measured and another is what we want. So to start with, we're going to need to be able to do things where we convert units between other similar units. For example, as shown on this slide, we have multiple different ways to measure mass. The primary ones for this class would be kilograms, grams, centigrams, milligrams, micrograms, and nanograms. And the question is, how do we get from one to the other? So first, before we actually do the conversions, we need to know what the actual relationships between these are before we can start doing actual problems. So for example, we need to know that for every 1 kilogram, there are going to be 1,000 grams. This is because a kilogram is larger than a gram. And what this means is we can now use this as a conversion factor. Because 1 kilogram is the same as 1,000 grams, this fraction is equal to 1. And as we learned in math class, we can multiply by anything by 1. Remember though, we do have to keep track of these units here. This isn't just 1 over 1,000 isn't equal to 1, but 1 kilogram over 1,000 grams is. In addition, we've got a number of others, so we need to know that for every 1 gram we can have 100 centigrams. In addition, for every 1 gram, we can have 1,000 milligrams. We can also have that 1 gram is equal to 10 to the 6th micrograms. It's got this little U-looking thing. Note that 10 to the 6th is just a million, but eventually it gets much easier to write 10 to the 6th than a bunch of zeros. And then finally we have that 1 gram is equal to 10 to the 9th nanograms, or a billion nanograms. So we can use any of these as conversion factors when we're doing our problems. You can also note that while I did this in grams, it would work in any other base unit. For example, 1 kiloliter would have 1,000 liters in it, or 1 liter would have 100 centiliters. So you can use any metric unit. It could be grams, it could be liters, it could be meters, it could be whatever we need, whatever metric unit we're working with. This covers most of the conversions we're going to be using in this class that you had to memorize. The one other we had to know is that 1 cubic centimeter is equal to 1 milliliter. And this will come up mostly because there are different ways to measure volume, and sometimes we'll need one or the other based on the other units in our equation. It's also important to note that each of these fractions, like this fraction here, all this is saying is that 1 gram equals 10 to the 6th micrograms. This also means anytime you see an equality statement like this, we can take this and we can put it into a fraction here that we will then use in doing our conversions. So now that we've got these, let's try doing some conversions with them. So these are the 4 conversions I'm going to try. So we're going to start with 125 kilograms. Note that while I'm going to use the right number of significant figures, we're not going to worry about that in this video. I'll make a follow-up video that works on making sure we keep track of significant figures. Although these will all be done in the correct number. But if you don't know yet why, you can check that one out afterwards. So we know that for every 1 kilogram, there are 1,000 grams. I want to go back to the other slide for a second to show you something. You'll note that here I had the kilogram on top and the 1,000 grams on bottom. But over here I had the 1,000 grams on top and the 1 kilogram on bottom. That's because since these fractions are equal to 1, either number can be on top and bottom. So how do I choose? I choose which number will be where based on the units. I know in my problem that I started with kilograms here. Didn't mean to go to the other slide. I started with kilograms here, and I know I want grams in the end, so I don't want kilograms in the top, so I'm going to have to get rid of them. So I put them down here in the bottom. This means because one's on top, one's on bottom, we're going to treat this like we would in algebra, where the units are just something else we can deal with, and the kilograms are going to cancel out. And this is going to leave us with grams. This is why we call it factor label analysis. Just make sure you keep your units with you, because if you forget one somewhere, your units won't work out right. This also helps out because if you end up putting the wrong thing on top and bottom, you'll get a strange answer like kilograms squared per gram, which while I guess technically a unit, doesn't help you a whole lot. So here, once we've done this, we have 125 times 1,000 divided by 1. From there, we get 125,000. So we have 125,000 grams. It made it all disappear. I'm still practicing working with this thing, and I do not know why it made that Oh, I changed slides. There we go. So we end up with 125,000 grams. And that box is over the 1. I didn't mean for that to happen. So we have 125,000 grams. And a reminder, in case you don't remember what these bars stand for, this is a way of saying we have 125 kilograms times the fraction 1,000 grams over 1 kilogram. So that's how we know that kilograms cancel. And this is why I need to take the 125 and multiply it by 1,000 and then divide by 1. Of course, if you divide by 1, it doesn't change the number. But sometimes our conversions won't have a 1 in the bottom, so just make sure you're multiplying and dividing by all the right numbers. Also remember that when you're just doing multiplication and division, it's communicative, so you can do it in any order. Dividing or multiplying by the top number or dividing by the bottom number first, it doesn't matter the order. As long as you make sure you put it correctly in your calculator so that you are indeed multiplying and dividing by the numbers you mean to. So, we will remove. Here's where I try to remember how I can. There we go. So, our second example. Here we have 475 grams. So in this case, I know I'm in grams and I want to go to milligrams. So if I want to get rid of grams, they're going to have to be on bottom. And then I know a conversion factor directly from grams to milligrams. So I can put milligrams on top. And we know that for every 1 gram, there are 1,000 milligrams. Our grams cancel. And when we multiply this out, we're going to get 475,000 milligrams. Eventually, I will adjust to my pointer completely, and I will not have that happen so much. So here, we got that 475 grams was equal to 475,000 milligrams. So these two examples have been similar in the sense that they only take one step to be able to get through. But a question comes up now. What do we do when we have something that has multiple steps? Here, we have 145,000 milligrams. And we're going to go to make our conversion. And we know we want milligrams on bottom. The issue is, I don't have a milligrams to kilograms conversion rate that I know off the top of my head. So what I'm going to need to do is I'm going to take multiple steps. The way I suggest you do this is you work through the base unit. With all the different prefixes and suffixes, we know how to get to grams. We know how to get from milligrams to grams or kilograms to grams. So we're going to do this problem as 2 steps. First, we will go from milligrams to grams. Just like in the last problem, we know there are 1,000 milligrams in 1 gram. Then we will go from grams to kilograms. Here, we put 1,000 grams on bottom and 1 kilogram on top. And we see that our milligrams cancel and our grams cancel. And now we just have to do both steps of this problem. Note that if you're really comfortable with it, it's fine to do it all as one step, but just make sure your numbers are right. But this is how you can do it by just memorizing the conversions I showed you. So here we have 145,000. We'll divide it by 1,000 first. We'll multiply it times 1, which doesn't change the number. And then we'll divide by 1,000 again. And then I'll multiply times 1. And I'm given that 145,000 milligrams is equal to 0.145 kilograms. So this is our way to do our conversion in 2 steps. So far, all the units have been in the same base unit. But sometimes we'll have to use other conversions because things won't be in the same base unit. For example, here we have a cubic centimeter goes to a liter. So here, first we've got our 1.5 cubic centimeters. We're limited by the conversions we know, but we know how to get from cubic centimeters into milliliters. In general, you'll notice this gets us to a similar base unit as our liter, even though it's not the exact right unit. That's one of your goals to try to get to, is get to a similar base unit if you're not already. So we know that 1 cubic centimeter is equal to 1 milliliter. There shouldn't be 2 milliliters there. So just pretend I wrote it once. I am going to rewrite that because it's bothering me. Now turn off the eraser. Eventually I'll get this. There we go. Nope, still an eraser. Okay. So now we've got things in milliliters. But that's not what we want. We want it in liters. So now we're going to convert from 1,000 milliliters to 1 liter. So now our cubic centimeters cancel. Our milliliters cancel. We'll be left with liters. So we take 1.5. We multiply 1, divide by 1, multiply 1 again, and then divide by 1,000. So when we do that, we are going to get that we have 0.0015 liters, which is how much that's going to be how many liters we have in 1.5 cubic centimeters. So that's a way we can convert from a unit that isn't in the same base unit. So we'll have to use some other conversion. So just in this case, we use the fact that 1 cubic centimeter equals 1 milliliter. As we continue throughout the semester, you will see more and more conversions, where in a lot of ways you're just combining a lot of these steps together, such as what we did when we worked on the mole in class, where then you've got to convert from moles, and then you just have to eventually you get it into grams, and then you might need it in kilograms or milligrams based on what your problem's asking you to do. But it's very similar to the work here with 1 cubic centimeter equals 1 milliliter. You'll just have to keep track of, you'll have a lot of different numbers, you just got to make sure you're doing the arithmetic right. Hopefully this helps out, and I strongly encourage you to work on problems similar to this, because this is going to make up a lot of what we do in the class. It won't be the only thing, but a lot of times problems will assume you're good at conversions later on, and that you can take these skills and then add them into other skills when you're doing other stuff throughout the semester.